Welcome to Unit 7, Section 2, Phylogenic Trees. Phylogenic trees show the evolution of traits through time. The evolutionary relationships between different species and their connection to common ancestors. Phylogenic trees not only show how closely related organisms are, but also help map out the evolutionary history or phylogeny of life on Earth. How are they constructed? Well, phylogenetic trees are constructed based on inferences made using comparative anatomy, comparative biochemistry, and studies of the fossil record. How to read a phylogenetic tree? To read a phylogenetic tree like the one in the next slide, look for the following information. First, common ancestor and relatedness information. The tips of the branches represent the species or other taxa the scientists compare. And branches meet at points called nodes that represent the common ancestor of the two taxa. Here we have a diagram. Notice A and B are connected by node number 3. So number 3 is the common ancestor of A and B. C and D are connected at node number 4. That is a common ancestor, the most direct common ancestor of organisms C and D. And E is connected to C and D by node number 2, which means C and D share common ancestor 2 with E. And number 1 is the common ancestor to all 4 organisms. The more two species are separated on the phylogenetic tree, the less related they are according to the theory of evolution. For example, C and D are more closely related than C and E because C and D share a closer common ancestor, node 4. There are 2 nodes separating C and E, node 4 and node 2. The evolution of traits. Traits that appear first will be at the bottom of the timeline, while those that appear last will be at the top. Species that appear above the appearance of the traits have the trait, while those below where the trait appeared on the timeline don't have the trait. How to read a phylogenetic tree, the evolution of traits. First of all, we know that time starts here. This would be the past. This would be the present. Now, trait number 1 would be vertebrae. According to this phylogenetic tree, vertebrae appeared first, before bony skeleton, 4 limbs, amniotic egg, and hair, and finally 2 post-orbital fenestrae, according to this particular phylogenetic tree. And the way to look at this as well is, let's say you have amniotic egg. Any organism that branches off before amniotic egg doesn't have it. So the only organisms with amniotic eggs are primates, rodents and rabbits, crocodiles, and dinosaurs and birds. While amphibians, ray-finned fish, and sharks don't have an amniotic egg. Same thing goes with bony skeleton. Every organism has a bony skeleton except for the one that branched off before bony skeleton, which is sharks. Phylogenetic trees are the final result of similar equals common ancestor. And it's trying to communicate evolutionary history, starting with the past and going up to the present. So this would be the timeline, starting here and ending on top. And according to, let's start by tracing the evolution of traits based on this phylogenetic tree. According to this phylogenetic tree, general organs would evolve first, followed by nervous and vascular systems. Then this would be 3, 4, vertebrae 5, jaw 6, digits 7, 8, hair and endothermy 9, 2 fenestrae would be 10, external skeleton or exoskeleton would be 11, placenta 12, and feathers 13. That would be the order of evolution of traits based on this phylogenetic tree. Besides that, you can also look at a phylogenetic tree and look at common ancestry. Looking at arthropods, insects, millipedes, and crustaceans all have the common ancestor P. Insects and millipedes are more closely related according to evolutionary theory because they're separate. They have a direct common ancestor. Insects and crustaceans are separated by 2 nodes. The less nodes separate them, the more similar they are. Insects and millipedes, 1 node. Insects and crustaceans, 2 nodes. So insects and millipedes will be more closely related. Now, looking at the rest of the phylogenetic tree, if I ask the question, what do you think is more similar, whales and cows or lizards and crocodiles? You might think lizards and crocodiles. But let's look at the phylogenetic tree. Lizards and crocodiles are separated by 1, 2, 3 nodes. Right? 3 nodes separating lizards and crocodiles. Whales and cows, 1 node. So according to this phylogenetic tree, whales and cows are more closely related to each other than lizards and crocodiles. And this type of information can be taken out of the phylogenetic tree just by comparing the number of node differences.